Well, I hope all of you enjoyed your coffee. I always put French vanilla in mine. At one time, I liked my coffee black, and I'm not going to add a pun to that, but I like my coffee black, but now I love French vanilla. I've acquired a taste for it, so much so that when I go to a restaurant, I have my wife carry in a baggie some French vanilla. Now, let's go back to work. Even though it is Sunday, and we've had a break, we've had a coffee break, so now it's time to go back to work. So this is going to be Parallel Resistances, Part 2. Now, if you notice, the actual values on my book have changed. Did you notice here that I've changed this value here? Now that's the total resistance of those four resistors put in parallel. And down here it asks for the calculated value, and of course that's 1.60. Now always add the unit, and in this case it's going to be ohms, OHMS. Now that I'm back, I'm going to reset my calculator, and I'm going to do this problem one more time. Now what I suggest you do as students, that you do your problems at least twice until you get the same answer. I keep track of my answers, and the likelihood of me making the same mistake a couple of times are a little high. So let me start over. The first thing I'm going to do is set up my calculator. So I turn my calculator to the on position, and let me discuss this again because it's important for my students to get used to using this calculator. Okay, now I hit second again, and what that's doing is putting me into the function that I'm going to hit with scientific notation, which is under the 5 on this calculator. Now notice that the exponents have popped up here, so I know now, and I can read it here, you probably can't, that I am indeed in scientific notation. Now what I'm asking for in this class is an accuracy of 2 decimal points. So I'm going to hit the second, and I'm going to hit underneath, I'm going to fix the decimal point, and fix is underneath the period. So I hit the period, and now I hit 2. And that gives me 2 places on my decimal point. Notice now that the machine is set up for 0.00 with 2 zeros in the exponent. Now, we want to start all of our problems this way in this class. Now, other classes, an instructor may ask you for something different. Now, for those of you who read the chapters on scientific notation, you know that there's a lot of set laws on how to add and how to subtract using scientific notation. Now, I think you probably should know that, but it's not necessary to do what we want to in this class. We want to be able to troubleshoot electrical problems, and we're not going to remember all of the rules, but it's easy to remember how to use your calculator, especially this calculator. Very simple, very easy to use. Now again, I'm going to do that problem once again. So the first thing I've done, I've set up my calculator. Now I'm in scientific notation. To solve this problem, I'm going to use this formula here. And the first thing I'm going to do is look at the first R1, which is right here. R1 is a 6, isn't it? So I'm going to put in a 6, and I'm going to take the reciprocal. And we notice that there's a plus sign. So I'm going to hit the plus sign. The next one is 8 ohms, and I'm going to put in the 8. I'm going to hit the reciprocal. I see another plus sign, so I'm going to hit plus. And the next one is a 12 ohm resistor, and I'm going to put in the 12. I'm going to take the reciprocal, and then I'm going to hit what? That's right, plus. And the last resistor is a 4 ohm resistor. I'm going to take the reciprocal, but this time I'm going to hit equal. And what do we get? Well, we know that's not a resistance value, 6.25 to the negative first. So what we're going to do, of course, is follow the formula, and we're going to take the reciprocal of that. So here I go with the reciprocal. And you notice that I came up with 1.6 ohms. So I write that down. I've written it down before. We've done that problem twice, and that's the answer we came up with both times. Now, I'm not saying that you're going to be right You could have made the same mistake twice, but the odds on an examination of you making that same mistake twice are probably high, because before you get to the examination, you're going to practice these problems over and over and over. And redundance and doing something more than one time will train your fingers, just like you learn to type, just like you learn to touch type. It will teach your fingers how to calculate this problem, sometimes without thought. Now, I know that all of you are heavy thinkers, but on the other hand, allow yourself the flexibility of having this drilled into you. Now, notice what I'm going to do now. Okay, I have the answer. I've talked about what I wanted to on how to calculate these problems. But in the meantime, let me give you some facts. And you've heard these before, but here they are again. In a parallel circuit, the resistor value of the total, and R total, is always going to be less than the smallest resistor. Now, does that make good sense? That RT is going to be less than the smallest resistance. Now, if you follow that and you get something larger, you're going to know you had a calculation error. Now, let's go on to the next part of this. I'm going to flip this over, and we're going to be working a lot of parallel problems. Now, notice here that I have a different formula, and this formula is called the product over the sum. And this product over the sum is derived from the previous formula. This is derived from that. Now, don't be confused by the RA times RB over RA plus RB. Let me explain that to a little bit to you. This is called the product over the sum. And what that means is that you take, say, R1, if you have two resistors, you take R1 and R2 times each other. And for the denominator, it's R1 plus R2. And we're going to do an example. Let's do that. RA is going to be 4 ohms, and RB is going to be 6 ohms. We're going to rewrite that formula. I don't like to use this RA and RB. In our class, we're used to R1, R2, etc. Let's forget the idea of RA and RB. Okay, now that we've done that, we take that R1 here is 4, and we take that R2 is 6, and these are ohms. You don't need to write those down right now, because now we know that you know what you're talking about. We're talking about resistance, so you know that those are going to be ohms. So what we do now, we take that's the product. 4 times 6 equals 24. Now we take the sum of those resistors, R1 and R2. R1, R2, the sum, and we come up with 10. Now, I'm going to clear my calculator, and I'm going to do that problem. Now, you and I both know that you could do that problem in your head. Trust your calculator, though. Under the stress of a test, the calculator is going to serve you well. So I'll put in 24, and that's divided by 10, and I come up with 2.4. And here's what we came up with right here, 2.4. Can you see that? Now, I'm going to say something now that may startle you, but I'm going to wait to say it. I don't want to startle you yet. So let's go on to the next item, which is on page 19, which is item 3. For any number of equal resistors in parallel, where R1 equals R2 equals R3 on out to the nth resistor, that there's a different formula that we're going to use, and this formula was derived from the first one that we talked about. Okay, notice here that RT, in this case, if you have equal resistors, RT is going to be the value of one resistor. The value of one resistor, and they're all equal, remember, divided by the number of resistors. In this case, RT was 50 ohms. I'm sorry, yeah. R1 was 50 ohms. One of the resistors was 50 ohms. Let's put it that way. Let me restate it. One of the resistors was 50 ohms. And the number of resistors, we only had 2. This is the number of resistors here. Notice that? And then the combination of those two together is equal to 25. Now, let's look at the example again. Find RT for 50 ohm resistors in parallel. So R1 equals R2 equals R3. We're using that formula. So we take a 50 ohm resistor, which is one of the resistors values, and we divide that by the number of resistors, which in this case is 2 resistors, and that equals 25 ohms. All we did, we reworked that problem again, and we came up with the same thing. I like to work problems twice. Now, I don't know about you, but I do make a few mistakes, and I try to do things at least twice to satisfy myself that I have the right answer. Now, let's do another one. Find RT for 300 ohm resistors. That's right, we're going to use that same formula. We're going to take the value of one resistor, in this case it's 100 ohms, and then we're going to take the number of resistors, and it says we have 3 of those. So we divide by 3, and we get 33.3 ohms. Now I'm going to do that a little differently though. I'm going to go to my calculator. Now I'm going to use the first formula that we had. And first thing I do, I clear my calculator so I don't have the same problem in there. And I know here that I have 100 ohm resistors. How many do I have? I have 3 of them. So the first thing I do, I put 100 in, and I take the inverse. I plus that for the second resistor. I put 100 in, and I take the inverse. Plus, I have another resistor. I put 100 in, and I take the inverse. And then I have to take the inverse of all of that. Right? So the inverse of that will be 3.33 times 10 to the first, which in fact is a 33.3 ohm resistor, as indicated here. Now notice that I used the first formula that we used. I used that RT equals 1 over R1, 1 over R2, that's plus 1 over R2, the reciprocal of, and the reciprocal of R3. And I came up with the same exact answer. What I'm recommending to you, and now you can go ahead and follow this if you want to, but what I'm recommending for you is to use the first formula that we discussed, the RT equals 1 over R1 plus 1 over R2 plus 1 over R3, etc. That formula will always work, and that's 2 less formulas that you have to remember. Now there would be cases where it would be convenient to use the product over the sum, or you could use the one with the size of the one resistor divided by the number of resistors when they're equal, but I prefer just to do them on the calculator. And I think in the future that you might find this to be the easiest way. But of course, if you get the right answer, and if you use the right formula and write it down on an exam, you will be right. But that's just my personal preference, and I wanted to pass that on to you. Okay, that was page 19. Now, we're going to turn the page, and we're going to go into problem set parallel resistances, and that's on page 20. Let me make sure I've got this into the light so we can see it. Okay, notice here that I've drawn a battery. I didn't need to do that. That's not necessary. That's just something that I was doing for another problem. But what I'm going to do now, I'm going to solve for 2 parallel resistors. In this case, I have a 6 ohm and I have a 3 ohm. Now I'm going to do the calculator again. Some of you told me that you were having a little problem putting problems into the calculator. So I turn the calculator off, I turn the calculator back on, I'm going to hit the second, I'm going to hit scientific notation, which is under the 5, now that I'm in the second function. I'm going to hit the second again, I'm going to hit the period, which fixes under there, and I'm going to fix it at 2 places. Now notice again that I have 0.00, and I have the exponent of 2 zeros. Your calculator is now set up, ready to work parallel problems. Now, the first thing I do, I put in the 6 here, I put in the 6 ohm resistor, and I say 6 reciprocal plus. Then the next resistor is a 3 ohm. So I put in the 3 ohm resistor, I put 3 reciprocal equals. Now I take the reciprocal of that, and I come up with a 2 ohm resistor. Now it did follow the rule that we had. The rule was that in order to have a in parallel resistance, that the total resistance is always going to be less than. We have a 2 ohms, and that's less than the 3, and it's less than the 6. You've just worked a problem so simple to do on the calculator. Now some of these problems, quite frankly, are easier to work because they're low numbers. Some of you will do those in your head. I recommend against it though. I recommend that you use your calculator for every single problem you do, because you're training your eye-hand coordination, eye-hand-brain coordination. Now I'm going to clear, and I'm going to get ready for the next problem. In this case, I have a 4 ohm resistor, a 6 ohm resistor, and a 12 ohm resistor. I do the same thing. My calculator is already set up. If you didn't do that, go ahead and set up your calculator. Okay, now those are 3 different resistors in parallel, and I want to know what RT is. Okay, what is the first thing I do? I punch in a 4 for 4 ohms, and I take the reciprocal of that. Now the next one is going to be a 6 ohm resistor. I put in a 6, I take the reciprocal of that. And the next one is going to be a 12 ohm resistor. I put in a, did I hit the plus? I don't remember. So I'm going to clear it. Okay, so I'm going to start over. Keep in mind that it's easy to let your mind drift on some of these problems. Okay, so I'm going to put in the 4. Okay, and I'm going to take the reciprocal of that. And then I hit the plus. Get it second nature. I'm going to put in the 6. I'm going to take the reciprocal of that, and then I hit in the plus. I'm going to put in a 12. I'm going to take a reciprocal. Now notice I'm not going to hit the plus this time, because I'm going to hit the equal. And you know that you're not there yet. You're going to have to take the reciprocal of that denominator. And here we go. And I come up with a 2 ohm resistor. Here it is worked out. And now we've worked 2 problems that you should have already worked. I'm going to do one more, and then I'm going to summarize and reiterate some things about parallel circuits. Now I'm going to do problem number 3. I want you to clear your calculator. Very important, clear that calculator. You clear the calculator, and I'm going to put in the 4 ohm resistor. I'm going to take the reciprocal of that. I'm going to put in the other 4 ohm resistor. I'm going to take the reciprocal of that. I'm going to put in the other 4 ohm resistor. I take the reciprocal of that, then I hit equals, and I take the reciprocal of the answer, and what do I get? I got a 4.00. Now I know is that wrong or right? Let's use the other formula. Let's product over the sum. Or would we use, which one would we use? We would take the resistor, the large resistor, and we would use this formula here, that RT equals the number of resistors into one of the resistors. Okay, that's 4. And I want to divide by the number of resistors, which is 3. I'll clear my calculator. I'll take 4 divided by 3, and what do I come up with? I come up with 1.33, and that's what I have here. Now I'm going to go through that problem again, because we must have hit wrong key when we're doing the parallel. Remember what we want to do? We want to do it at least twice, and we want to get the same value. So I'm going to clear the calculator. I'm going to put in a 4, take the reciprocal, plus. I'm going to put in a 4, take the reciprocal, and then plus. I'm going to put in a 4, take the reciprocal, then equals, and then I'm going to take the reciprocal of that. And notice what I get. I get 1.33. Now I've just demonstrated, not on purpose, I did make the mistake, not on purpose, that if you're not watching carefully what you're doing and focusing your mind, that there's a chance that you're going to forget to do one or two things on the calculator. You're going to either forget to do the reciprocal, or you're going to forget to hit the plus, or at the end number you're going to hit the plus again. You don't want to do that. Follow the steps that I've given you, and you will be able to solve these problems very rapidly. And you and I both know that time is of the essence when you're doing an examination. Now let me review again. There are certain things that you need to remember. You need to remember that in a parallel circuit, the resistor RT is always going to be smaller than the smallest resistor. With that said, I'm going to stop the recording, if I can. I think my screen just went blank. There it goes. It went into standby mode. I'm going to stop the recording, and I'm going to see if I can send this onto YouTube.